2 log, open parenthesis, x plus 1 equals 1. We're supposed to solve this equation for x, and we have to check our answer and make sure that our answer is correct. So, in order to find value of x, first I have to eliminate the coefficient which is next to logarithm. I have to divide both sides equation by whatever is multiplied to my logarithm. 2 and 2 will cancel out. I have log x plus 1 is equal 1/2. This is the common log. This is invisible base 10. I'm going to convert the logarithmic form to the exponential form. And I'm going to have 10 to power 1/2 equals x plus 1. Next, in order to find x, I have to move 1 to the left side. And I'm going to have 10 to power 1/2 minus 1 is equal x. I can rewrite this equation as x equals 10 to power 1/2 minus 1. And this is the solution to my problem. Next, we're supposed to verify that this is correct answer. So what we're supposed to do, we're supposed to replace this x in original equation by this value. I'm going to have 2 log, and instead of x I have to write 10 to power 1/2 minus 1 plus 1. Minus 1 is from here and plus 1 is from here. I have this logarithm equals to 1. Negative 1 plus 1 is equal 0. And I'm going to have 2 log 10 to 1/2. Because negative 1 plus 1 is 0, I don't write it. Equals 1. Next I'm supposed to use the property for log of power. This 2 is going to be my exponent for 10 to power 1/2. I can rewrite this equation as log of 10 to power 1/2, and everything is raised to the second power, and everything is equal 1. We have to use the properties of exponents and simply multiply external exponent by the internal one. So 2 and 2 will cancel out. And I'm going to end up with log of 10 is equal 1. Keep in mind that this is the common log. Common log has base 10. Anytime I have log where the base is equal to the domain, you're supposed to keep in mind that this is equal 1. And I can say that left side is equal to the right side. This is the proof that the value which I got for x is correct. So this is the final solution to my problem. Let's take a look at this example. Please notice that we have logs with the same base. On the left side of the equations, subtract from each other. Please keep in mind, anytime there is no coefficient next to the log, there is always invisible 1. So we have to combine the like terms. 3 log base 2 of x minus 1 log base 2 of x is equal 2 log base 2 of x is equal 2. I can eliminate this coefficient by dividing both sides equation by 2. 2 and 2 will cancel out. 2 and 2 will cancel out. And I have log base 2 of x is equal 1. Next, I can convert the logarithmic form to the exponential form. I'm going to have 2 to the first power is equal x. 2 to the first is simply 2. 2 is equal x, or x is equal 2. This is the solution to my problem. But we have to verify if our answer is correct. I'm going to replace every x in my original equation by 2. I have 3 log base 2 of 2 minus log base 2 of 2 has to be equal 2. 3 log base 2 of 2. We have to use the property for the logarithm which has the same base as the domain. This logarithm is equal 1. In this case, I have base equal to the domain. That's why this logarithm is equal 1. Minus log base 2 of 2. Again, base is equal to the domain. This logarithm is equal 1 equals 2. 3 times 1 is 3. Minus 1 is 2. 2 is equal 2. Left side of the equation is equal to the right side of the equation. That's why this is correct answer to my problem.